Good evening. Well, at least it's good evening for me. It's about 10 o'clock where I'm making this. Welcome to an overview and examples of how to calculate risk and return. First, what is it? Well, return is how much you'd expect to get for something, and risk measures how volatile, how risky it is. We use the measure standard deviation to calculate risk. And why do we care about risk and return? Well, if you're going to invest in something, you want to know how much you can expect in return and how much risk goes along with it. With most things, you can expect a higher return for higher risk, but you want to balance those out. Sometimes you'd prefer to get a lower return if you can achieve lower risk, or sometimes you'd rather get a higher return and you would accept higher risk for that. We're going to go through how to calculate return and risk under two different types of cases. These two cases are one on the left here, where there's variable numbers with known probabilities. Throwing dice is an example of this. When you throw a die, you know there's a probability of 1/6 of getting a 1 and 1/6 of getting a 3. Those are given. Now that's different than a case where there are no known probabilities, only historic observations. So for example, looking at temperatures over the last 3 days, you could observe the high was 70 degrees 3 days ago, 60 degrees 2 days ago, and 50 degrees yesterday. So those are two different cases because in this case, there's no probability given, whereas in this case, like with throwing dice, there are given probabilities. Let's start with where they're given probabilities and how to calculate expected return. So suppose we have this case where the demand for a company's product given in column 1 can be under 3 scenarios: strong, normal, or weak. The probability of demand occurring shows 30% for strong, 40% for normal, 30% for weak. Note, these have to add to 100. Even if there's 4 different possibilities, or 5 or 100, they all have to add to 100. And column 3 shows the rate of return under that scenario. So under strong, which occurs 30% of the time, the stock would grow by 50%, and 10 and negative 10, and so on. Note, the probability represents the likelihood of something occurring. For example, there's a 30% chance of rain or stock increasing by 10%. That doesn't mean it'll actually happen, but there is a 30% likelihood. To calculate this, the expected return, we use this formula here where we're multiplying probability of the first instance, in this case it'd be 50, times that return, 0.3. We're doing that for each case, so we take 50 times 3, 10% times 0.4, that's number 2, negative 10 times 3, and on for each different case. We add those up, and that's represented by this formula. Probability for I times the return for I, and sum those up to get the expected rate of return. Now, let's calculate it. 0.3 times 50 is 0.15. 0.4 times 10% is 0.04. 0.3 times negative 10 is negative 0.03. And when you add those up, you get 0.16. 0.16 is the same as 16%. So the expected rate of return is 16%. Now we're going to look at the standard deviation, which measures volatility. So if the actual results are very spread out, then there would be very high volatility. And let's compare two different sets of outcomes. One where there's a stock either grows with a return of 100% or a decline of 60%, or going down by 60%. So up by 100 or down by 60. The second stock either grows by 21% or, I should say, instead of declines, has a return. Let's say has a return of 19%. So here, with the first case, you'd have higher standard deviation than number 2 because there's much more volatility and it's much more dispersed. But you can imagine if you graph lots of outcomes, and one stock was all over the graph and the second was tightly concentrated around a number, the first would have higher standard deviation than the second. Conceptually, we measure volatility as how far the outcomes fall from the expected outcome. So in the basic example above, both of these average 20%. The first half of the time 100% and half negative 60% versus the second 19% half the time and 20% half the time. So we measure standard deviation when there's known probabilities using this formula. Standard deviation, shown here, is the sum of each outcome minus the expected return squared times the probability, and you add each of those up. So let's go and calculate that using this formula. So we found the expected return for these are 16% by multiplying each of these up and adding it up. So the first step in this equation is to subtract, get the deviation from expected return. So number 3, 50%, minus column 4, 16%. So that's 34%. Make all these red here. And then we have 10% times 16%. Is negative, sorry for the pause, is negative 6%. And negative 10 minus 6, negative, or minus 16% is negative 26%. Now, we did that, so we took Ri minus expected return, R, in each of these cases, and now we square it. So we take 34% and square it, which is 0.1156. Do it again for negative 6 is 0.0036. And we do it again for negative 26%, 0.0676. Oops, jumping ahead, don't do that. So we have 0.1156, 0.0036, 0.067. Now we multiply that, we squared it by the probability. So we take column 6, and we multiply it times column 2, the probabilities, and we get 0.03468, 0.00144, 0.02028. Then we sum them all up, right? Each of these cases to get the variance, which is 0.0564. And now we take the square root, which is the standard deviation. So the square root of the variance is the standard deviation, and that's 0.23748, or 23 point, let's say 75, we're going to round. So what we did is we took the difference, right, to get the deviation here. We squared them in this column. We multiplied by the probabilities. We summed them up to get the variance, and then we took the square root to get the standard deviation. So in this case, the standard deviation is 23.75%. Now we're going to turn our attention from that case where there were known probabilities to where there's only observations. Average return is the average of actual occurrence of something. So say a stock actually returned each of the following. So 1 year it returned 15%, 1 year negative 5%, and 1 year 20% over 3 years. You take the average by adding them up and divide by 3. So 30% divided by 3 is 10%. Right? and it would look like this. 15 minus 5 plus 20 divided by 3 is 10%. We show that with this R average, where we're adding up each of the RTs, where T is each of the instant, and dividing by the number, so in this case 3. And we say these past realized returns are shown as R hat T, or R bar T, where T designates the time period. The average annual return is known as R hat average. And that's what we got here, 10%. Now, for that same kind of instance where we just have the historic observations, we're going to look at how to calculate standard deviation. Standard deviation of the sample returns can be estimated using the following formula. We're going to use this case where we had 15% one year, negative 5% the second, and 20% the third, for an average of 10%. To calculate the estimated standard deviation, or S, we take each of the instances, subtract the average, square it, sum those up, and divide by n minus 1. Here's how it would look for this case that we're talking about. (15 minus 10), because 10 is the average, so 15 minus 10, square it. And remember, order of operations matters, so we square that first. We also add that to the square of negative 5 minus 10 squared plus 20 minus 10 squared divided by n minus 3 is the n minus 1. That gives us 13.2. So in this case, standard deviation is 13.2. Now we're going to look at how we do that same standard deviation calculation in Excel. So we had negative 15, 15% in the first year, negative 5 in the second, and 20% in the third. To do standard deviation in Excel, we use this, STED. We just highlight those three and calculate the standard deviation of 13.2. So that was the same calculation that we did here to come up with 13.2 that we did by algebra. Lastly, we're going to talk about coefficient of variation. And so what that is standard deviation divided by expected return. So let's look at these two securities, or two stocks. Sue's Shoes had an expected return of 5% and risk, or standard deviation, of 10%. Techno had an expected return of 30 and risk of 30%, standard deviation 30%. So if we take the ratio, be 10 divided by 5, that's 2, where 30 divided by 30 is 1. So the coefficient of variation is much higher for Sue's Shoes. So there's a lot more risk relative return. Even though Techno is a lot more risky in total, we may prefer Techno because the coefficient of variation is lower. So we're getting a lot more return based relative to our risk. So in this little lesson, we learned about return and risk, standard deviation, under two different types of scenarios. One where we have known probabilities, and one where we don't have known probabilities, only observations. So we saw how to calculate risk, standard deviation, and return under both, and then we saw how to calculate coefficient of variation. Thanks a lot.